Assalamu alaikum wa rahmatullah. Today we are going to learn how to establish IPv6 networks, and also we are going to learn how to configure the OSPF version 3 to support IPv6. I recorded a video using the old or the previous version of the ESMB simulator, which is 1.2. 1.2 actually is not supporting the IPv6 and not supporting the OSPF because that version cannot run the AR series of routers, which is needed to run the IPv6 and OSPF. Okay, to run the IB version 6 and OSPF version 3, actually you cannot use the generic router here. I will tell you, I will show you why. I will put one router here, generic router, and also I will put another router here, which is AR series. So let us run the instance of this routers. Then we see how it works. So this is the generic router and this is the AR series. Okay, it will take a little bit time. We have to wait until it starts up. So now this one already started up. System view. If let's say we configure the IB version 6, it would work even on the generic router. But the problem after that, after we configure the IB version 6, we have to run the OSPF version 3 because OSPF version 2 is not supporting IB version 6. That's why OSPF version 3 is not supported here, and you can see it by yourself. OSPF version 3 1. Enter. And this is the error that we face even in the previous version of the ENSP. So that's why we updated this version 1.3, which is able to run especially over the Windows 10, and also it can run over Windows 7. And using this version, you can easily run the AR series router. So here you can see there is an error over the generic router, but if we go to here to the AR series, then we run the same command, OSPF version 3. You can see that the command is already running. So this router is running smoothly, properly, and it can support the OSPF. Okay. For this reason, we have to delete our previous topology that we have created in the previous video. Actually, the previous video I shared with you, but after I found the solution, I already deleted from the Bootstrap Blast and also from the YouTube channel. Then you are not going to find it. But anyway, anytime I mentioned the previous video, I am talking about the deleted one. Don't care about it. We have to follow the video. I already shared with you how to install this version of ENSB, the version that supports the IB version 6 and the OSPF version 3. So you have to follow that video to install all needed softwares. Then you, after that, can follow my lab, this lab. Okay, so in the previous video, I created this topology using the generic router because in the previous version, this router is the only one that we can run. But for now, we can run the AR series. So I'm going to delete all of this. And after that, like this, delete, delete. Then I have to insert here router 1, router 2, router 3, because we need to follow this topology exactly. the topology that we have in our lab sheet. Sorry, I forgot to read for you the objectives of this lab, because I already read in the previous time when I recorded the previous video, but because I deleted that one, I have to repeat it. So this lab actually is to teach you how to configure the basics of IB version 6. So you will learn how to configure, how to assign addresses to the network interfaces. And after that, you will learn how to configure the OSPF version 3 to support that IB version 6 addresses. Then later, we will learn also how to enable the DHCP version 6 also to support IB version 6. And after that, we will see the verification of the results using IB version 6 display commands. So here we have router 1, router 2, and router 3. The only thing that we need is to, I forgot something actually I have to mention as well, because this one, the cloud is also needed to be configured. So for this reason, also I have to delete this as well, or maybe I will delete everything from here to make it like a fresh one. Then I will show you how to make the things. Okay, so when we drag the cloud from here to here, it would be empty like this. I just kept this because this one is cloud 1. I don't want to delete it, then we keep cloud 2. That's all. It's nothing more than that. Just follow this. So now this cloud is empty as the fresh one. Okay. So the thing that we need to do is only to select the GE here. Don't tick this, because if you tick this, you have to do the configuration manually. But leave it unticked. Then add 3 links. Why 3 links? Because we need 3 links, 3 physical links to be connected to the 3 routers that we want to use. Also, we have to go here as well. We select the GE, and we have to select the local port here 1 with 2. Click this two-way channel, insert. So here we can see that this, because this one is two-way, it inserts 2 port mapping rules. So the first port mapping rule is from port 1 to remote port 2. And this one is from 2 to 1. Then we have to insert also from 1 to 3 and from 3 to 1, as you can see here. Then we have to insert from 2 to 3 and from 3 to 2. Okay, so in total, we will have 6. Sorry, it doesn't, we cannot maximize the window. So you will see here, we have 6 rules inserted to the port mapping table, and also 3 interfaces inserted to the interface table. After this, we just close. Then we go to the link. We select copper or auto. Then we come from here. We select the GE000, because in the lab sheet, they use the G000. So we select here the G001, and from here G002, and from here G002 interface 3. Okay, so everything is smoothly done. We can arrange the things here to look nice. Okay, so now the thing that we need to do now is to click on the white space here. Then we click run or start devices. Now it could run the AR routers, but the previous version cannot run. So hopefully everything is going to be smooth, and inshallah we will not face any problem. Okay, now we open this AR, open this also. So if one important thing I want to show you, if let's say you double click on the routers and you see multiple windows here, you can go to any CLI window and you click on this button here to combine them as multiple tabs. So now we opened AR1, AR2, and let us open the AR3. I think I have to close the WhatsApp because it makes noise for me. Yeah, okay. Here now we have the 3 routers are running and everything is fine. You can see the green colors here, all the interfaces are up. Let us go through this here. Here we have to assign IPv6 for the interfaces here. As you can see, if E80:1, if E80:3, if E80:2. Actually, this range of IPv6 addresses, we had already taken this in the class last time. So if you forget this, please go back to the slides and understand what is this. If E80, or maybe I show you now to save you time. So this is the IPv6 slice. Okay, quickly, I'm not going to explain the things, but only to remind or refresh your minds. So here the table. If E80, double colon, if E80 is link local, unicast address range, and also here we have FF021 and FF022. You have to refresh the things in your mind in order to understand everything. Also, in here, we have to assign this IP addresses for the loopbacks 20011 and 20013 and 20012, this one ACP. So here, if we want to go there to the slides, we can see the things here. So this one, this range actually is the current global unicast range. So these IP addresses are global IP addresses, while these IP addresses are link local. So you have to refresh that. So I will close this. Then let us go to the scenario here. I want to read the scenario for you. In line with plans for deployment for solutions for next set of solutions for next generation networks, it has been decided that the enterprise network should implement an IPv6 design to the existing infrastructure. As the administrator, you have been tasked with the job of implementing the addressing scheme and routing for IPv6, as well as providing stateful addressing solutions for IPv6. So if you forget also the stateless and the stateful addressing, you have to go back to the slides and refresh it in your mind. Then you can come back and understand what is this. Okay. Let us now go step by step. So the first thing we have to do is to prepare the environment. So we have to be in the system view first. Then we also need to rename our routers to be R1, R2, R3. So to do so, we have to go this, okay, before we start, we have to do something. We have to do something. We want to undo terminal logging to avoid the automatic logging that disturbs our commands. It's annoying, actually. So we have to undo this. Current terminal logging is off. So in order to undo this, you have to be in the user view, not in the system view. So we have to run this on all of our routers. So we stop the auto logging. Then after that, we can go smoothly, system view and system name R1, this one. Or maybe because this one is AR1, and for this system view, system name AR2, and the third one system view and system name AR3. So here we are, we already renamed all of our routers, the 3 of our routers. Then after this, we have to configure IPv6 addressing. So here we can see establishing IPv6 global unicast addressing on the loopback. So for the loopback, we are going to use the global unicast addressing, which is starting by 2001. And manually configure link local addressing on interface gigabit Ethernet 000 of all routers. So we have to assign the link local addressing for the G00 of all of these 3 routers. So the link local is going to be used to allow these 3 routers communicate with each other. Then the loopback 0 IP address is going to be used for testing. So loopbacks have to use global unicast addressing. Okay, let us go step by step. First, we have to go to router 1. We go to IP version 6. So this command is only to enable the IP version 6 on the router. Then after that, we have to select interface loopback 0. We enter the interface view. Then after that, we have to enable the IP version 6 on the interface, because IP version 6 have to be enabled on the router. Then after that, we have to go inside every interface view that we need to use the IP version 6 and enable it using this command, IP version 6 enable. Then after that, we have to, now we are at the loopback 0 view. So here we have to assign IP version 6 address 2001:1:A space 64. Actually, the 64 here is the prefix, which is representing the subnet mask for our address, for our IP address. Okay, this is already done for the interface loopback 0. And now we are going to quit from the loopback 0 interface view. Then we have to go to the interface gigabit Ethernet 000. And here we have to enable also the IP version 6. Oh, sorry, IP version 6 enable. Then after that, we have to assign IP version 6 address. Here we have to assign the link local IP address. So FE80:1 link local, like this. So here we are, everything is done. So you can see what's the logging here. And now we have to go to router 2. So in router 2 also we have to enable the IP version 6 first. Then after that we have to go to interface loopback 0, and we have to enable the IP version 6 using the IP version 6 enable command. Then here we have to assign IP address. So the IP address here is going to be, because now we are configuring the loopback 0, we have to use the global unicast address. So global unicast address is going to be 200:2:B space 64 for the subnet mask, and hit enter. Then after that, we have to quit from this interface. We go to the interface gigabit Ethernet 000, and we enable the IP version 6 enable. Then we have to assign IP version 6 address, which must be a link local IP address starting with FE80:2 link local. This one is wrong. :2 link local. Okay. So here we are. We already done the router 2, and now we are going to use to configure router 3. So we have to enter the system view again after the timeout. So here we have to enable IP version 3 also, and we go to interface loopback 0. We have to use this command enable, then IP version 6 address, and here the loopback is 2001:3:C64, and quit. Go to other interface gigabit Ethernet 000, and also IP version 6 enable. Then IP version 6 address FE80:3 and link local. So here we are. Everything is done. Okay, now we have to display the configuration of our routers. So let us go to router 1 and use display. This display command actually can be written fully, as you can see in the lab sheet, and also can be shortened as DIS, display IP version 6 interface gigabit 000. Hit enter. You can see here the status of the interface is up. The protocol's IP version 6 protocol current state is up also, exactly similar to here. Then we can see the IP address. IP address is FE80:1, exactly similar to here, and also no global unicast address configured because this one uses the link local. So global unicast is assigned to the loopback. Then here we can see the joined group addresses. So you can see FF021 here, FF021, then also FF001 exactly. Then after that 21, as you can see here, exactly similar to the results that we have here. And also here that is 1. If you forget what is that, you just go to the slides and refresh it. Everything is similar, 30,000, 1,000, everything is similar to the lab sheet. So that means everything is smooth, works fine. So we have now to go to the configuration of the OSPF on the routers. So the first thing we have to do is to configure router 1. So here we are on the router 1. I'm not sure, clear or clean. I forget the command to clean the prompt. Anyway, now for router 1, in order to use the OSPF version 3, we have to use this command, OSPF version 3, and we have to give a number for our OSPF profile. So normally we use number 1, especially if we don't have multiple configuration for the OSPF on the same router. But if we have multiple configuration of OSPF on the same router, then we may use multiple profile numbers. For our case, we are going to use the OSPF version 3 and profile number 1. So here we are inside the interface of the OSPF version 3. So now we want to assign the router ID, router ID. It's supposed to be 1111. So router ID in the OSPF version 3 still following the format of the IB version 4, because its length is only 32 bits. So we have to manually configure it. Then we assign the router ID, we quit. Then after that, we go to the interface, gigabit 000, and we have to use the OSPF command, OSPF version 3, then 1, which is the profile number, and after that we have to mention the area that we want to use. In our case, actually, we are going to use a single area, which is area 0. So we have to be in the area 0 view. Then, so this command actually OSPF3.1 area 0 is only to create the area 0 profile and the OSPF version 3 profile on the gigabit Ethernet 000 interface. So now, after we created it, we quit. Then we have to go to the interface, loop back 0, and also we have to create OSPF version 3 profile number 1 and area 0. After this, we already done, quit. We go to the router number 2. Is there any mistake here? No, no mistakes. So we have to go to router 2. Guys, it's better to follow the instructions, but not only to follow. You try to understand. You try to understand why we use these commands, why we do this. Is it in this sequence necessarily, or it can be in different sequence of commands? You have to understand. You have to learn. Otherwise, you have to do a lot of job. So you just give it time and try to understand what you have run in this lab. OSPF version 3 space 1. This is only to get inside the OSPF 3. And here we are going to use the router ID. So we want to use this router ID for this router. Then after that, we quit. And we go to interface gigabit Ethernet 000. And we use the OSPF command version 3.1 area 0 to create the profile. Then after that, we quit and we go to interface loop back 0, and we run the same command. Okay. Hopefully it's easy for you to understand. Here we are, we're done. So we go to router 3. Okay, now at the router 3, we have to also use the OSPF command to create the profile. Then after that, we quit. Oh, sorry, not quit, router ID 3333. Then we quit, interface gigabit 000. OSPF 1 area 0. Then we quit and we go to interface loop back 0, and also we run the same command OSPF version 3.1 area 0. Here we are. So everything is running smoothly. Now, if we run this command, display OSPF3 pair, command on router 1 and router 3 to verify the OSPF version 3 pairing has been established. So let us go here to router 1, as you can see here. So we run this display OSPF version 3 pair. Okay, so it's already established, exactly similar to what we have in this lab. Okay, we go to router 3 and we use display OSPF. Here. We also can see 111.222. So here, this one is actually the router 1 is the DR, which is the designated router, and the router number 2 is the BDR, which is the backup designated router, and router 3 is DR other, which means non-DR and non-BDR. So everything fortunately runs fine, smoothly on this version of ENSP. After this, if 111 is not currently the DR, the following command can be used to reset the OSPF version 3 process. So if you want to reset the router 1 OSPF, you can use this command. Reset OSPF version 3, 1 graceful dash restart. But this one is only if the 111 is not currently the DR, but in our case, it's already DR. So this is the command if you want to reset. I'm not going to use it now. So now we are going to test the connectivity. In order to test the connectivity, we have to go here on router 1 and we ping IP version 6 FE80:3 minus I gigabit Ethernet 000. If you want to test the router 3, the connectivity from router 1 to router 3, actually you can do this. You can do this. Let us try first. So now it's working smoothly. So if you remove the interface here, it's not going to be responding. Why? Because the interface is not known. We have to tell the router number 1. We have to tell router number 1 is that if we want to reach this IP address, which is the link local of this interface at router 3, so we have to tell this router that in order to reach this IP address at router 3, you have to forward the ping through the interface gigabit Ethernet 000, this one. After we forward here, then the cloud will deliver it to the other interface. Otherwise, it's going to be showing this message. Please specify an interface name for the link local address. Okay, so now connectivity is okay from router 1 to router 3. Let us go to router 1 and ping the global unicast address on router 3. So in order to ping that global unicast, you have to use this command, ping IP version 4, then after that 2001:3:C. Okay, so this is the IP address that we have configured for the loopback on AR router 3. So now the global unicast is already accessible or reachable. Connectivity is fine. So if we want to check the other router, router 2, so we have to use this. From router 1 to router 3, and router 2 is working properly. Okay, that's all about the configuration of OSPF version 3 and IPv6. Now we are going to learn how to configure the DHCP version 6 to distribute IPv6 addresses. Enable the DHCP server function on router 2 so that devices can be assigned IPv6 addresses using DHCP version 6. So instead of configuring the IP addresses manually on all routers, we are now going to enable the DHCP version 6 on router 2 only, on router 2 here. Then any connected device can get an IP address automatically from the DHCP. Okay, in order to do so, we have to go to router 2. Then here we have to be in the system view first. Then we run the command DHCP enable. Okay, so here the operation may take a few seconds. Please wait for a moment. Done. So here, this is only to enable the DHCP server. But yet is not mentioned. Is it DHCP version 4 or DHCP version 6? But in our case, we need the DHCP version 6 because we are using IP version 6. So in order to do so, we have to use DHCP version 6 command, DUID, and is it this one is double column, DUID double L. So here we receive this message. Warning, the DHCP unique identifier should be globally unique and stable. Are you sure to change it? Yes. So after this, we have to enable the DHCP version 6 pool. So we have to create pool number 1. You can use whatever name. You can use my pool, for example, public pool, local pool, private pool. It's up to you. So this is only name you create. And now, as you can see, we are at the pool 1 interface view. Then here inside, we have to use this command, address prefix. Then we use 2001 colon FACE face, okay, double colon /64. Okay, so this is only to give the range for the pool. So the pool, next time when any device is connected to the network, the DHCP server will take an IP address out of this pool. So that's why we have to identify, we have to set the IP address range for the pool to be used later. So now the address range is already configured. This one, as you can see, 2001 face double colon 64. Then we have to use this command DNS server 2001 colon 444E colon 5300 double colon 1. So this one actually is going to be used when a new device is connected or attached to the network. Then if this device is seen by the router 2, then router 2 will automatically assign the IP address out of this range here, and also will assign the DNS server exactly as we have configured here. Okay. Also, we can configure the gateway and everything similar to what we do in IPv4 networks. So, okay. So here now we are going to exclude address 2001 colon face double colon 1. Okay. This IP address is not going to be assigned to any device. Okay, if you don't remember why this one 200 colon then something then ends by 1, why we have to exclude, you better go to the slide and refresh that thing. Okay, we just quit. Configure IPv6 functions on the Gigabit Ethernet 000 interface. So here we have to go and enable the DHCP server function on the interface. So we still at the router 2, we go to interface, Gigabit 000. Now we are inside the interface view. So we are going to use the IPv6 address 2001 colon face double colon 164. Okay, so what we have done here. So here we have used the IP address. We assigned this IP address, which we have excluded this. We have excluded it from the DHCP pool. Here we excluded it. Why? Because we want to manually configure it to this interface. The interface that we want to enable our IPv6 pool on it. So now we use this IP address. After this, we can say DHCP server version 6, DHCP version 6 server. We attach the pool 1 to this interface, because we can create multiple pools, and every pool can be assigned to 1 or 2 interfaces. And also we can create, for our DHCP, we can create a global DHCP pool. Okay? So here, what we have done now is that, I don't know where is the drawing tools on this. Okay, to explain this for you, okay, suppose that we have a router here that's connected to multiple networks, and suppose that this interface is 0, this one is 1, this interface is 2. So here inside, if let's say we create a global pool, so global pool, if let's say here we have a switch, and if let's say we have multiple PCs connected here, then these PCs, 3 PCs, can get IP addresses automatically from the global pool of of this router. Okay, but also we can create here another pool, for example, pool 1. Then we attach it to only interface number 1. So only computers coming through the interface number 1, they can use the range of pool 1 to get their IP addresses here. Okay, so also we can make, for example, pool 2, then we assign it to this interface. Then if let's say we have another switch here and other computers connected, then these computers will get their IP addresses from that pool 2. This is the concept, the main concept of the DHCP pools and everything. So hope everything is clearly understood. Okay, we have done this. So we attached the DHCP server pool 1 to interface 00 on router 2. Okay. Here is our last command, DHCP version 6 server pool 1. So now we need to enable the DHCP version 6 client function on router 1 and router 3, so that devices can obtain IP version 6 addresses using DHCP version 6. So for this reason, we have to go to router 1. We enter the system view and we follow these commands. So the first thing, we have to enable DHCP feature, DHCP enable, and DHCP version 6 DUID double L. Double L, if I'm not mistaken, means link local. So we hit yes here, and we go to interface gigabit Ethernet 000. Enter the interface view, then we go to IP version 6 address. We make it auto, because last time we manually assign the IP address to this interface. Now we are going to release that manual IP address, and we enable the auto DHCP configuration, DHCP. Oh. Okay, so now this interface doesn't have manual IP address, and it's going to get its own IP address from the DHCP that's running on the router 2. Okay, let us go to router 3. We do the same thing, system view. Then we have to run DHCP enable. This is only to enable the DHCP service. And also we run the DHCP version 6 DUID LL. Yes. And after that, we have to go to interface gigabit Ethernet 000 on router 3 also. And we have to make it auto DHCP. So here, IP version 6 address auto DHCP. So here also we release the manually configured IP address, the one that we configured in step 2 in this lab sheet. After this, we have to display now, run the display DHCP version 6 pool command on router 2 to check information about the DHCP version 6 address pool. So here on router 2, actually router 1 and router 3 now doesn't have manual or static IP addresses, and we configured them to get dynamic IP addresses from the DHCP version 6 on router 2. So that's why we have to go to router 2. We check how many IP addresses we already leased to other devices. So if we run this command, display DHCP version 6 pool, so we will see the information here. We have DHCP pool name is pool 1. Address prefix is this. This is the whole range that we assigned for this pool. So we excluded here. Let us check this first. Lifetime valid is this. So the validity when we lease an IP address to router 1 or to router 3 or whatever devices on this network, the device will keep the leased IP address for this whole time. So 172,800 seconds, and the preferred is this one. And also here we have two IP addresses already assigned, already leased to. One is leased to router 1 and the other IP address is leased to router 3. So here we can see the excluded IP addresses, the one that we excluded. So one excluded address in total information refresh time is this, and the DNS server is as we configured, and also conflict address expire time is this time. Active normal clients are 2. So these two clients are the router 1 and router 2. So exactly we got the same result as we have in this lab sheet. So now if we go to router 1 and router 3 and we run the display IP version 6 interface brief, we are going to see the result. Okay, display IP version 6 interface brief. This one is to show you the brief summary about the interface. So here we can see, you can follow this one, down administratively down, exactly. Then loop back and spoofing, exactly. Then interface, physical and protocol, interface, physical and protocol. So gigabit Ethernet 000 is up, the physical interface is up and the protocol is up. The IP version 6 address is this, the one that we get from our DHCP server at router 2. So if you remember at router 2 here, we excluded this IP address 2001 phase :1. Then the following IP address is this one, 2001 phase 2 is assigned or leased to router 1. And if you go to router 3, you will find the 2001 phase :3 assigned to router 3. So here the loopback 0 is up, the protocol is up, the IP address is exactly as we manually configured. So let us go also here to router 3. We check that router 3 is also configured automatically. So we check the IP display IP version 6, IP version 6 interface brief. So here we are. We are going to see all of normal results. So interface 000 up, and the IP version 6 address is coming from the DHCP server on router 2. So here we are. We see that IP, the one that ends by 3 is assigned or leased to router 3. So here loopback 0 is up, and also the IP version 3 address is 2001:3:C, which is manually configured by us. So everything now is done smoothly, run smoothly. So if let's say we want to run Bing command exactly similar to what we have done, let us use Bing IP version 6 2001 colon face double colon 2. This is only to ping router 2 from router 1. Then here minus I G gigabit Ethernet 000. Error, no need to specify an interface for the global unicast address. Okay, this one, yeah, because this one is a global unicast. Oh, sorry for that. Yeah, this one, actually, we want to bring the global unicast IP address. We shouldn't specify the interface. Okay, it works fine. Then here, if we want to bring router number 3, I don't know why it doesn't work. It works. Maybe it takes time because this one is a simulation based on the virtual machine. So that's why it takes time sometimes. Yeah, you see it works properly. Okay, here we are. Everything is fine. Alhamdulillah. So you can follow. Please give it time to understand everything. Please try to make multiple scenarios to understand the configuration process and the steps, the sequences of commands, and so on. So hope everybody is understanding very well. If you have any question or any unclear things, please contact me on WhatsApp. Send me your questions, and I'm going to answer it as soon as I can. Thank you very much, and have a nice day.